In this video, we are going to work through the following example. It says, considering only the values of beta for which the cosecant squared of beta times the cosine of 2 beta is defined, which of the following expressions is equivalent? Okay, so what we're going to do is try to use some of the identities to transform this expression into one of these. Okay. All right, so looking at this expression right here, the thing that sort of jumps out at me first of all is this cosine of 2 beta. Okay, so that just looks like the double angle formula. So looking at the double angle identities, I can see here that I have cosine of 2x, and I have these three choices: cosine squared minus sine squared, 1 minus 2 sine squared, and 2 cosine squared minus 1. So I'll need to pick one of those three forms to change it to. And looking back at our problem here, I can see that I have cosecant squared beta. I know that cosecant is 1 over the sine. So when I look at that, I guess thinking that probably the sine is a good choice here. This one in the middle, 1 minus 2 sine squared. Now, that's not to say these other ones won't work out. They probably will work out just fine if you chose one of those. But just that's the one that kind of jumps out at me because of the fact that I have this cosecant squared here. Okay, so oops. So that's what I'm going to do. I'm going to use and I'm going to change this cosine of 2 beta to 1 minus 2 sine squared beta. And I'm just using brackets here because of the nested parentheses. It's just a little bit easier to look at. So these are just parentheses. It's just easier for humans to look at this, right? As opposed to having a bunch of the same looking parentheses, okay, in there. And I need these at least some parentheses around this because of the fact that I'm replacing cosine 2 beta with an expression that has two terms. 1 minus 2 sine squared. So when I multiply this out, which is what I'm going to do in the next step, that reminds me, hey, that I need to distribute this cosecant squared beta to both of these terms here. Okay. All right, and like I said, that's what I'm going to do next. I'm going to go ahead and multiply cosecant squared beta times 1. And of course, I'll just get cosecant squared beta. And then when I multiply cosecant squared beta times 2 sine squared beta, I'm going to get 2 cosecant squared beta times sine squared beta. When I do that. Okay? Okay, and so now I just want to keep simplifying. And one of the reasons why I chose this 1 minus 2 sine squared beta is because I knew that, well, cosecant is 1 over the sine. So there's probably some simplifications that I could do here. And so that's what I'm going to do. So remember, right, we have this identity up here. Cosecant is 1 over the sine, right? This reciprocal identity. So off to the side. I know that this is an identity, right? And so therefore, if I square both sides, that will also be an identity, right? And when I square this fraction, I square the top, which is 1, and put it over the square of the bottom. So this is also an identity. And so I can use this identity over here to simplify this expression. And so when I do that, cosecant squared beta minus 2. Cosecant squared beta would be the same as 1 over sine squared beta. And that's times sine squared beta. Okay, and so so that leads me to sort of the next simplification that I could make, right? I can rewrite this sine squared beta as sine squared beta over 1 and go ahead and multiply these two fractions together. When you see that, you'll notice, hey, I have sine squared beta. That is a common factor between the top and the bottom, the numerator and the denominator. So I can cancel those common factors out. And so what I get when I multiply these two fractions is just 1. And then 1 times 2 is 2. So you can see that greatly simplifies the expression that we have to deal with. So it's now boiled down to this. So going back to the original problem and taking a look, trying to look to see if that is one of the choices that we have, and it's not, okay? So it's not any of these choices. So I'm going to have to do a little bit more work here. And looking at the choices that I have, 2 minus secant squared beta, 2 sine squared minus tan squared beta, and 2 sine beta, and then cotangent squared beta minus 1. Looking at those, the expression that I have, cosecant squared beta minus 2, it looks maybe this one is not that far off. It has the 2 and a squared secant, but I really want a squared cosecant, and I want this to be backwards. But that might be a possibility. This one also looks pretty similar, right? I have cotangent squared beta minus 1. I just have a 2 instead of a 1, so that's kind of ruins that one. But of those ones that I have, those two definitely look the most like what I've got. So what I want to do is try and think about, okay, how would I change what I've got, this cosecant squared beta, into either a secant squared or cotangent squared. So what you would do is go look back through your identities, right, and see if you can find something that relates cosecant squared and the cotangent squared. And so if you look back up at these Pythagorean identities, right there is one that relates cosecant squared. That's what I've got. And possibly it also relates cotangent squared, and that's possibly what I want to have in there. So that to me looks like that's an easy thing to change in there. So I can just take cosecant squared and replace it by 1 plus cotangent squared. So that's exactly what I'm going to do. So cosecant squared is the same as 1 plus cotangent squared beta, and minus 2. And then you can see now I have some like terms. I have this 1 and the minus 2. So I could rewrite that as cotangent squared beta minus 1, right? Because I have a negative 2 plus 1 will come out to be a negative 1. And that is exactly one of the choices that I've got. And so that would be the answer that you would select on this problem.